presentation, you will say less swearing than before. First of all, thank you for being here. All these things that we usually say. I pre-apologize for all the swearing that I will say, and I'm surprised that you are here because I'm not sure if you know what you're going to see, because the title is it's a crap. Before we have been here for 20 minutes preparing this. This is live stuff. Ah, what doesn't work is your computer. Oh, that's great. It's true? Okay, let's go. Because of Cesar's choice, because he doesn't want to use good things, he forced me to use Google Slides. So if you want to follow the presentation live, you can follow on that BD code. We activated the comments, and if we have time, we will answer those comments. And if not, we won't. But you can get it in live if you want to have them closer. We will try. If you enter through the BD code, you will see this. This doesn't work. You go too far. Okay, this wasn't prepared. But what's the length of this remote? 13 minutes. Well, presentations. Well, you introduce yourself or not? What do you do, Danny? I'm Danny. Those who don't know me. I'm Kron is my geek name. And as it says here, I'm devoted to research. I break things. Sometimes I do things. I like to use hacking tools. Right now, DevSecOps is fancy. We do these kind of things, and also I do things in Python. I'm Cesar Gallego. To define myself, it's very complicated. I'm a polygeek. I move wherever I find curious things, and most of the cases that's not good thing because I end up having trouble. And professionally, I devoted myself to process terabytes and terabytes of data. And half of my career, maybe less, I'm working with Danny in innovation, learning a lot about security and doing cool things. There you have our LinkedIn's and Twitter profiles if you want to ask something and give us some love. As something happened, Twitter is silenced because you troll us while we're doing these speeches. This disclaimer is mandatory because through LinkedIn you can know where we work at. But our opinion are just ours. Let's not think that our employers say that this breaks like this, it's like that, or whatever. This is very important. We want to preserve our jobs. This doesn't work. Let's talk about core concepts on CI/CD world. Why did they invent this? Because it's heaven. And why this is idyllic and wonderful, we have to say it everywhere. Continuous integration. Before we continue, please, can you make us a favor? Can you raise your hands, those who know what continuous integration is and what continuous deployment is? So with that, we can skip faster or slower. Most of them know. Well, yeah, why not? Okay, go ahead. Continuous integration. We put Wikipedia's definition in case we have a problem. It consists basically in that at a certain point someone was suspected of compiling and automated it. So there were tools like had some, then it moved to Jenkins, and those tools that let you compile in a machine in a centralized way to your code, so you couldn't blame to your colleague or the guy next to you because it wasn't compiled properly or whatever. Then continuous deployment was born from the need, well, okay, we have everything compiled, but I want to reach production as soon as possible. So they started making automated software to get that code to production. The people who do it right, in theory, deploys dozens of time in production per day, even if those who follow very strictly say that every commit of the repository must reach production. But imagine this problem. Each commit And who reviews that? What if it's wrong or if it's broken? So among this sandwich, we start having many techniques like testing, tune, infrastructure as code, that became very trendy because of the fact of trying to achieve production constantly in many occasions. We will see why afterwards. Here, there's a big difference between delivery and deployment. If we click here in this pointing thing, it says this: when you do continuous delivery, normally there's a person who decides to send your things to production, but when you do the continuous deployment, there's no human parts there. That's like a shotgun. What enters gets out from the other end as quickly as possible. But what happens if we live in a previous world, let's say? What happens if you don't have no CD, no continuous deployment? We know this from the old world. You have a developer who takes the code somewhere. There is a Jenkins, in this case, which compiles it, and someone who put it in production. We put it like in cloud because cloud production is what it's called now. What other scenario can we find? None of those. There's a developer which put it in a code repository where it puts the artifacts that are already done, and there's another ops guy which eventually gets there when someone hits him or when he decides that something to be repaired and send it to production. And there's another scenario which is hell, in the case that there's a developer which has no code repository and pushes to production things like a real cowboy. So please raise your hands, those who have this problem in your work. Has someone lived this? How many have to deal with this crap? Raise your hands. Don't lie, please. There are some reasons we said what it is, but we didn't explain the reasons from which this is raised. CI/CD comes to deliver value to clients faster and more frequently. It became popular after the great boom of internet and having more real-time users interacting with applications. That need of companies of competing among each other. If we go a little bit backwards and we think how was it done before, you had these waterfall projects. In 5 years we're going to implement an application. You started with an army of programmers and QA slaves, and they create a huge code pyramid and they put in production. The biggest companies like Facebook or Google, they were pioneers in these things, started deploying many months, years, days, and now it's several times per day. Thanks to this popularity and that many companies had embraced this philosophy of delivering continuous value and being more competitive, now we have an ecosystem of applications that can be used for CD or CI, excuse me. Some of them can be used for each or for both. And it's a complicated scenario. As usually, in all these technical developments, at the beginning there are few actors within a technological landscape, and when it becomes more and more popular, there are new softwares, new competitors that do it too. The level of security, this is quite interesting because suddenly you have a lot of softwares that do the things differently, but their security concerns are different. What is pipeline? We all know this, but a pipeline basically is a software that chains processing elements, which is quite obvious. But when you start researching what is a real pipeline, they say to you it's BAS pipeline, the data pipeline. Now we have many types of pipelines, so we'll keep it simple. They are elements that of chain of software processing, of course. What is DevOps? DevOps comes from the DevOps culture of stop passing problems among each other, because as we said in the previous environment, which is legacy, no, it's back, or you put it in production. Oh no, but my computer is working. So basically, DevOps is about is forcing the dev to work with the ops. It's more work with the same money, for the same money. Here's a sentence that we hear a lot in the DevOps world. You have to eat your own food. You create a software and then you suffer it, because it's very usual that you create a software and then someone else had to worry about the software. And this generated within the CI/CD cycle was that illusion of, well, the ops is stopping my project, but it doesn't work. So that debate didn't reach any point, and the cycles were delayed. And when the DevOps culture that we're living nowadays is more implemented and the cycles are working better, now we make the mistake of security. Now that the ones who stop security, the production is security, but the DevOps, the dev and the ops agree, and they think that it's okay. DevSecOps is about, for the same money, to introduce another profession in the same box and try that security is another value to provide in your continuous and in your in CI/CD cycle instead of being just an obstacle. Okay, let's go. This is a typical setup with all the cool words that Cesar told us. I'm going to be there. These cool terms like pipeline, CD pipeline. Basically, it's summarized in this diagram, let's say. That is, the developer connects the code. It goes from left to right. Somewhere, it goes through the pipeline, construction pipeline in different steps, and then we have another pipeline, which is the one that publishes on the internet or whatever it needs. If we just divide it, there are some pieces missing. In the left part, the developer, and on the right hand you have the cloud, because otherwise you are no one. If we just split it, we have this picture. We put the user because those who are devoted to security know that most of the problems are caused between the chair and the PC, so that's important to note down. So among all that, those imaginary things, there's a lot of software that which do all the things. Please look on the right hand side because there's an FTP protocol icon. Maybe if you don't have suffered it, this file is copied in FTP file, which is not true. And the other thing is you deploy it wherever you want, or on the right hand side, or in your own hosting. So far, so good. So as we know what heaven is, we start with hell. Let's start to get into the matter. We thought that this picture was nice because it means that things become more and more not nice, let's say. Let's start from the left part, which is the code. If you realize, we put a source code and not repository of versions or stuff like that, because the version control repository can be the PC of a user. So we put it in the source code. So the first and most stupid thing is that for developers like us, except for Cesar, they use an B like IDE because they think it's a development IDE. I am Dever because it's an IDE. That creates a project file and if we are not careful, all files are treated like that, and even if there's not much information, you can always obtain and you gather all together, and in the end you can start like doing dirty things. Another thing, we move to the version control server, which in the end as a version control server, even if it's not a prepaid layer, that in general you assign a role to a person. In this case it's GitHub, but everything works the same, or Masters of the Universe, or whatever, the role, whichever you want, but be careful. No one lets you filter at the level of file or folder, at the level of whatever you want. It's just basically binary. You have access, or you don't have access, or when you have access, free to go. And if you don't have code repository and you are Christian, you have to pray. So, production machine. Here we're talking more about what happens when the developer has the code in his or her machine. We have some questions here to help us in our day-to-day basis, to let us think and see the problems that we can find, because in the end, I don't think we're going to show you nothing new, but The environment it needs to be clear, and how all the concepts clear. It's very important. So questions to be answered. Is there any cowboy developer in your project or in your team? Do you know if the cowboy developer is the guy who says, okay, I fix it and send it to production when it's a Friday night? Then we underestimate our software. Okay, this is small, this I keep it in my computer and I send it everywhere, and it doesn't happen. Even if the software that has been developed to automate support for the own pipeline itself, and have to take into account. Bring of device, it's very important. We have to take into account that the code must be saved. You have to do backups and you have to keep your working space safe, because if your machine is compromised, the developer machines is compromised, the code, depending on the relevance of the code, could kill that guy. I look for a cool picture.
Another one that's very typical as well. It's like a temple. You are a developer. You write down the question that you get in the screen, and where do you go? Overflow. If you're going to program, then you need a computer, is the same, or a programmer. You all have used Stack Overflow, which is great, but it does something great. In Stack Overflow, there are people who, rather because they don't know any better or deliberately, some people write the wrong things deliberately. So if people cut and paste this, who controls this source? Libraries. Yeah, well, another common problem is that the developer says, I found this wonderful library made by a Russian that solves all my problems. I'm sure it works great. Well, we have to be careful, because not everybody doing libraries are great people or good people. And the fact that it's in GitHub doesn't mean that it's production ready. People think that because it's in GitHub, it's great. Well, not necessarily. It may be put there by a crazy Russian. This is a news item connected with this. I don't know if you remember, not yet a library that was quite popular that had malware within in one of the transitive dependencies. And you don't notice because it's so fast. Whenever you install anything, it takes ages. This is incredibly obvious, but have you've done this because you're bad guys. APIs or AP keys, or if you have a machine and you have no money, then you look for the Amazon AP key, and somebody will have left it there. And if you do not find it in GitHub, then go to another even cheaper option. But somebody has to control this beyond the people in the CS to have to deal with to people from the CRN to have to deal with all the shit, really. So, okay, let's move on to the building step. Things start going on here because we begin to have our own automated script, and something that looks silly, but it's a good practice, is that the bot that we are using, whatever it is, when it downloads the code, it should do it in read-only mode, because somebody that's in the pipeline maliciously can do maliciously code changes, and if the CI/CD is not well logged, then the signer of that commit would be the CI/CD. And if you have a lot of controls further left that have gone all of, you have already made all of the checks, and then as the code is downloaded, as Cesar says, before everything else happens, you modify it. You can introduce bombs or whatever, and this is quite an unusual thing. Not a lot of people do it, and it's actually very simple. Artifact control. if you are unlucky enough to have to code in artifact Java, when the code that the developer codes is over, it usually ends in a library or an artifact that ends up in a central repository. And who controls what's uploaded to that artifactory, to that library supplier? And what about if the programmer is a bit of a bad guy and introduces a Trojan into the library? And if intentionally the developer uses a library with known vulnerabilities and publish it, because then it has a colleague that then maliciously intervenes, and then they spread the benefits. So there's the developer, there is the bot user. They all have to have limited privileges. And regarding the repository, many artifactories have policies so that you cannot publish with the names of popular artifacts. I could Trojanize Spring. Imagine if I Trojanize Spring and I upload it to the repository, because that would be a mess, because it's a very popular library. What happens with the environment? Often from the CI/CD we have to connect to places, and we call that environment variables. And if these variables are not well defined as secure, what can happen is that somebody maliciously can take those connection data to do damage from elsewhere. And in fact, I don't know if you've ever, because you have strange hobbies like I do, in the Travis console, do you know this CI/CD from SERP? There are people who do variable echoes in consoles because they don't do them well, and if you scratch down, you can find passwords in remote places because they are not properly marked, or things that you should never, ever do. So at least if you mark them as protected, and we can't fight human stupidity, but at least let the software help us. A reverse shell in the pipeline, it's incredibly easy to open because many pipelines have execution permissions of whatever, user permissions of any code. Jenkins has a sandbox, but very often it allows you to execute any operative system command, and it has to be good enough for you as a developer to be able to build your code. So you have to take into account where you are allowing it to execute itself, and to limit where you can move to, because why should the part that deploys in production access to internet? Should it? And if Jenkins doesn't deploy in production, why does it have access to a machine? So this is a demo, and let's hope that the gods of connectivity are with us. It's very silly. We open a netcap, we're in a very weird port, and we're going to do what Cesar has mentioned. We go to a Jenkins, and if we are free to create jobs, tasks, etc., we set up a script. And the virus is not mine. I've just removed the boring parts. But if I get a kiosk and it's not so complex, you cut and paste from GitHub the IP on wherever you have yours, and go ahead. You might not see too much, but what the Jenkins does is it executes the job, and it ends up by connecting. It's a new shell, but this author of this virus hasn't gone too far. You could go much farther. And then there are the permissions for Jenkins. It shouldn't be all powerful, because if the Jenkins bot does what you tell them as developer, and you tell the developer do not touch production, but the developer tells the bot to touch production, that's silly. It's one more step, but you're not doing anything. So it's very important for bot access to be correct and appropriate for the task they have to perform. And here we have the super powerful bot. Okay, so about the evil agent. Let's imagine a frame architecture, Jenkins, which is so popularly used. If you have a Jenkins architecture which has n agents, there's a master and all of these agents where the jobs are sent to and executed. What happens when at a point in time you receive a task or Jenkins files, for instance, that does something that shouldn't do? What if somebody decides to download an nmap from the agenda of the Jenkins? Can you do that? Well, the nmap installs a lot of libraries, but somebody has compiled it in static. So as a demo about this, and for us to see what can happen if you allow an agent to do its own thing. And this is our virus, so any criticisms concern us in this case. So the job is executed and the clone downloads the code, and precisely what we are doing is we have downloaded an nmap that was compiled in static. It's my computer that's slower because there are no apples on the cover. So we're doing a CUR or a CUR, downloading it directly from GitHub. So we see it very small here. The 127 is doing a scanner of a port of the agent itself. So what can we emphasize here? First of all, we've done a CUR, and why not Groovy or even Java? Because as a security measure for sandbox, precisely it won't allow you to save files on the disk for security. But you can first execute the scripting. Great. Then we use the CUR and that's it. But as we've said before, if you have an evil agent, then the nmap, with that you can send, after the nmaps with the script, you can do exploits or great stuff. And it allows you to do whatever you want. This is also connected with the network infrastructure. This is very serious, depending on whether your agent is in a container and where it lives, because it lives in a flat network and there are interesting stuff around, then we're in trouble. So as measures, of course, limit internet access, particularly in GitHub, and as Cesar has said, careful with the infrastructure and indeed careful with permissions. This is the first chapter in hardening. It's actually pre-hardening. So yes, nobody cares if you can access everything from everywhere. So this is something we learned in another talk about the lambdas, which this free IP. And at that time, nobody in Amazon had access to Google, and that can happen here. If you have free services that are not obviously free or limited by IP, just to be a bad boy, you can do a small script that calls them aggressively and then wait and sort of run out of IP share. And that can happen with Jihad that has user limits if you don't have the enterprise user. And so you end up receiving messages that you can't go any further, it's over. And if you lose access to capabilities to use Jihad code, if your pilots are there, you can do away with everything. So this is like sort of off your eyesight until it's. And imagine if you have containers with Docker Hub. Well, if you run out of share of Docker Hub, then you have to start looking for services and put them in a for two lines. And you make a mess of for the administrator because they do not know why they're limited the services, and you do away with your share in this case. The JIT bomb. One of the things you can do with JIT, and this was more popular a while ago, but it's still in the back of our head with the GitHub versions, you can create a repository that never ends cloning itself. You can you can stop a pipeline, definitely, and that means that an agent is out of combat. A couple of pipelines in this way, and you can not build anymore. So you have to be careful with the active versions of JIT. And this, by the way, with the later versions of Jenkins, it doesn't happen because it has a timeout. And you have to take that into account if your repository is very big. And this is okay since JIT had put its repositories elsewhere. It has releases. And what's beautiful about this, depending on which side you stand on, because turning a normal Git repository into a clonable one is just downloading a small app and executing it. So any developer you have, if they are in a bad mood, when they go up to GitHub, the changes in the unclonable repository has done away with the pipeline, and it's a complex attack, and it depends on whether you have a timeout, but and you're going crazy without knowing why it doesn't finish with the cloning. This one also has become famous, that a lot of people were creating indiscriminate containers with Docker Hub, unaware that they were publicizing a lot of sensitive information from the company. So careful with the copy. If you cannot review the layers, at least the Docker file, and you should have an alarm when somebody uses a copied dot. That can, and this is the writer of the article about this. And there's something else. When it does the Docker building, and we have found that people, when you tell them, realize, but not before, if you do a copy dot and you copy whatever you need to copy from the code, but there is additional information, sensitive information or confidential information that are copied as well. And then in a posterior run, you delete that, and I publish it, and that's it. You know that Docker doesn't work that way. As long as when you have copied it, it's one more layer. And the fact that you add other layers on top, nothing stops you from removing other layers until you go to the initial layer where it was copied. And the files that you deleted are still there. And this sounds silly, but it's a great way of finding secrets, just going layer after layer backwards. And we've done tests with this, and it's great. The wonderful stuff that you can discover, depending on which side you're on, of course. And we also have to keep in mind that the API has to be safe. Even those who still have Jenkins has still many open issues in some of the plugins that still keeps the credentials in flat text on the hard disk. And with those credentials, you can do a lot of damage to the CI/CD as soon as you have access. And we've seen that it's not so difficult to have access. This one from 2019. So these CVEs when you update the software, the machines that are touching internet, the productive machines, but the construction machines, it looks like you put them there once and then they stay forever. And we have found an incredible amount of machines with infinite CVE, and the developers seem to be very serious and they do not know what a CVE. And well, there are people who are smarter than us, so we have to be careful. Okay, so the analysis, or the forever analysis, very often we do vulnerabilities analysis, static analysis of the code, what's going on, and all of a sudden you put that through the CD, and there's a, and then are those security controls executed again? Because a software that at the time was was secure because it had analysis, security analysis, it doesn't mean that it stays secure. So it's a very good practice to try, even if it's not executed through the pipeline, at least taking that very code that you have deployed and put the security checks on them. It's a very good practice.
At least in some places, you need to know which dependencies on software do you have. When we started doing a project about this in GitHub, we realized that nobody did this. Once they are in production, they don't care. And the version, the release of Spring like 8 years ago, what happens with the previous versions? Did you become old and there it is? This one has happened too. That's why it's here. Ransomware for source code. That's crap. Is if this ransomware exists, it's because it works. So keep that in mind. I posted a piece of news from 2019. All pieces of news are from this year or previous year. And a man here who was walking around all the code, all the repositories, and introducing a ransom. Also, break history. We have to think about this. We have to know who accesses your codes, and if you have many outsourcing in your company, you have to consider the life cycle of the onboarding of these people, what they do, and how long are they able to do it. Especially if you have a lot of rotation, because there's people who do bad things, and they want to remove from the history what they have done. So you have to also, if you receive. I request a person outside to do something, and they request a commit, and that moment they break something. If they do a pull request, you have to review that because there's a lot of kind, but you have to do it. It's a lot of work, but there are many shells that have entered through that way. This one is for you. This is an attack that is older than Jesus. I think it's 20 or 30 years old, but as a concept, it's still valid. But we have to confess that we haven't found proof of concept until we told it to another Russian colleague of us, and he said that he could create it. Create it in 2 days. What's this all about? We can have a signed, certified pipeline or whatever you want, but if the compiler, the one which generates the artifacts, is injecting the bugs, it's the same. Do you know what I mean? I mean, imagine you're in the Java virtual machine with the Java compiler. If Java compiler injects the bug and tells you this is built, now go sign it, upload it, there's no human way to realize that basically you have been bugged. I insist, this concept has existed for many years. It's interesting to put it here. We put it here because it's important to highlight the following. Please, you have to certify the tools, the construction tools, whether that's it, that's the compiler. The compiler, it's a very important tool, and we assume it works and that's it. I'm not going to talk about GCC because there's no much code. It's not that common that companies just code in C, but Java, Python, Golang, they make a distributable version. All these kind of things, is there until someone gets crazy and starts doing this kind of stuff, and we find that, or the Russian guy does it, who's crazy. If you let him do it, he does it. The fat Docker, it's not just a fat Docker can cause two things. First, build a layer that lets you without disk, or you have a big Docker and you have to move it because of your infrastructure. So just as an example, and a picture of a Docker, it's 12 gigas and you have to deploy it through Kubernetes. Your network is on fire. So it goes against the philosophy of CI/CD, which is we want to be fast, and we allow Dockers of the size of Texas. That's not normal. We have to merge that with what we said, and you inherit any library from where. If you have a bad idea, you create an image of a Docker of 2 terabytes, and then you inherit from that. Moving through Kubernetes will be a joke. It's important to highlight that the image must be big, but destroyed pieces that are small. Otherwise, it won't make sense. I love this picture. It's the evil Docker twin. This happens. We have to be fast. When you put the hash in the from, you don't know where this picture comes from. I can generate a Docker image from Nginx, and you can edit with everything I put inside. It's annoying to put all the hashes, but you have to put it. It's better if you don't have a central Docker hash. Deployment. It has cool demos. We're going to the last step. So we have mentioned this and on who accesses internet and when, and which things access among each other. For instance, we have several agents, and it's a good idea to let them access among each other. Among them, it's not a good idea because of the cases that we have mentioned. An agent kills other agents. It can be possible. This one is quite relevant. It's a case that was proposed by a colleague, Robert, and he told us that you have to take into account that we are saying about delaying the pipeline and making everything slower. Who cares about that? In the end, it's just more hardware and that's it. But something that happened is that a person who is working inside, maybe in an outsourcing, has conducted a security analysis, has discovered a vulnerability, and is delaying it voluntarily while someone outside is explaining it. That's something that I wanted to mention because we have to keep that in mind. There's no mitigation for this except for beating that guy up, and kill people is an ugly thing. It's an ugly thing to say. The jar Trojanized a jar. It's quite easy. There's a Python tool that you can find in GitHub. It's wonderful. It's quite easy. Imagine now we have a similar demo, not with a jar, but if the artifact that you publish is the jar, and when the applications read it, will read mandatorily. It's like the outrun of CD. Any jar can be Trojanized the same way. Jar can be applied to constructor phrase. In the moment it's executed, you have a bug. It's as easy as Cesar said. Trojan in GitHub, and there are 2 or 3 Python codes, easy to use, and are very annoying. Also, we have to consider the security, the infra code. There are many advantages to this. Those who make the infrastructure as a code should be aware of the security and what about he's doing, especially if they are generating the infrastructure as a code in a critical part of the production, and to separate role. It's not useful to create infrastructure as a code with the developer and with another kind of supervision. That is, the DevSecOps is fine to save money, but sec words should be sec letters should be big. Imagine that they create things in Amazon that they shouldn't. That kind of things. I'm going to talk about how many of you know what a thief bomb is. It's very old trick. Those who don't know it, a few people raise their hands. They are tired. A thief bomb is a zip file that when you are going to decompress, you are creating in a specific way that will never stop decompressing. How does it work? But basically the algorithm is every time you try to decompress, the software that you use creates more folders, more files in a recursive way, and you never decompress it. It has funny attacks like the ones we're going to see, like giving it to a user in a mail, and okay, that's it. The PC is over. You have to say what I will explain afterwards. What's below. These kind of attacks can end in two consequences. You have your disk full, or if you have a timeout, the process will block and will occupy a lot, and that's it. Except if, these people from Vietnam, not because they are really good and doing hardening of machines. Their machines that we download from them are very well hardenized. Maybe the zip file detects if you have a possible zip bomb, but it detects under certain situations. But sometimes we can ignore that. So the demo that we're going to run now is quite silly. Do you know that all the hardware doc in the end it's a zip file? Did you get that together? So it's a zip file. When you click on double egg doc document and you put a zip bomb in, okay, that's it. And if you get a word with a zip bomb and you know that Tomcat is wonderful and you let the word and it lets you deploy it, and if you do it, what happens? Make a small video. It happens that Danny's computer is broken. You will see. What we're seeing is the upper part is the system that we're going to break, doing a DF, which is updating from time to time. We will copy the Tomcat with the word directly to the machine with the Tomcat. So once the Tomcat, this new file, we'll try to apply it. We'll try to decompress, to open the application all the time. Copy it. Okay, we go to the monitoring of the system. This is happened. It took like 1 hour and a half to break, and if it's interesting, the most thing you see the use of the disk until the virtual machine broke. It took 1 hour and a few minutes. Why is this relevant? It's very relevant because of one reason. First of all, direct consequences. We have filled the disk with just a zip file because it's not well securized, and it took 1 hour. That means that the one who is about to analyze the machine, there's no action reaction when after an hour the event, you can blame it to another thing, but in this case, apart from being a bad thing, is a good thing if you are the attacker. I have to say something about this. Then you run the machine. There's no room, but the Tomcat doesn't to deploy the war for a simple reason, because it between event change. So that's it. So protect against symbol system limits. What's hardening timeout, and that's it. Memory bond, which is it's less known that memory bomb. It's quite easy to do. You have it in many languages, even for shell. We can see how my computer breaks because the video is wonderful. You just fill the RAM, and when you have more RAM, the swap is used, and if no swap available, disk. So it's wonderful because it occupies everything. I put it in a Jenkins. The order. If we put it in the pipeline, what may happen? You put it here like another script, because it's a script, is sh, and a piece of code like this. It's very silly. So you put in here, you see the master push it to an agent. Okay, do this job, and this this agent explodes because the memory is complete. Then it says it sends to another master, to another agent, until you run out of agents. This is as severe as depending on the resilience of your agents. And if I'm corrected, this is delay, but that's it. You break the whole infrastructure in a waterfall, like with 8 characters, which is that a memory bomb. You will see now, as interesting fact, there's an orange thing, which is the word clock of the machine. So now, as I'm going to execute the script, I have to click it very fast, because even if I run, my mouse starts doing weird things. It's executed again. It downloads the pipeline, the repository, the code repository, and it runs something subtle like boom sh. And then you have a word clock of 360, 669, and it keeps increasing. When it reaches 3000 something, the progress bar is dead already. The spinner is dead. My mouse is dead. Well, that weird movement is the one that I did to see if it works, and now it's moving. You are now in 2000 of workload, and it doesn't make it. As you have the agent that deploys by default the master next to the master, you break it all, because that machine just explodes. Wait, because the machine continues. So we had to capture this with an external capture, because the computer just exploded and died. We have seen some death here. That's wonderful. We're going to talk faster. Well, you can look for us afterwards if you want to have some questions. We're going to ask for more fork bomb. Is exactly the same, but more known. The video is exactly the same. The machine tends to die when you run these things, but the fork bomb takes a bit more time to die, but it dies eventually. This interesting thing about the memory bomb is that memory bomb sometimes has prevented that Tomcat wrote the log when it's in the master. So once you just run a memory bomb and there's no trace that you have run that, you just broke it and that's it. The only thing left as trace is that it skips the number of build. When you do a fork bomb, it reaches the end and tells to everything's fine, and it dies. So they are difficult to detect, because in the first case everything's fine, but it dies with honor, and you go back to master, everything is successful, and then the computer breaks. You must monitor your system, of course, as if CI/CD was software. Be sure that there are no dishonest things in your APIs. There are tools to do it, but it's very important. Don't let humans touch by hand production. That's vital, because you really know which is the status of the machine, of the production machine. You are sure that there's nothing there to do evil things. The infrastructure is our best friend in that point. Passwords. Basically, this is easy to explain. This is difficult to explain. When you are developers and you connect a database, just introducing the password, what impedes you from when you are in production to do a CUR to do in the production and send it to a connection? There are proxies for that to have to authenticate, and they give you back the token. This is super weird to be implemented, but that would be the right measure. It's not more complex to program, but it's much safer. The developer has the Trojanized Docker, and same as a previous case, but with Docker. But also you have to keep secrets well, safe. Infrastructure, it does have 3 things. Alias, even it's stupid, it's something like an old-fashioned stuff, but you can change the functioning of a system, a command system, a system command with an alias. Imagine that you do those changes, those cool things. You might you send the password to someone, or every time you do a make kvir, which is interesting thing, and they break your machine in very quickly. Like a pseudo demo, we're going to do these things. Every time that someone runs an ELS, we're going to send all the environment variables to Tomcat, because we want all the variables and the environment. So we put an alias with ls. It's just sending the credentials to the netcat to the port 999. we load again bash rc to see it work, so we don't have to reboot. We run the DLS, and that's it. That's stupid. Be careful with shared infrastructure. CI and CD must not share infrastructure. I know it's there are VLANs or VPC, or if you are more modern, there are agents deployed in production, and APIs must have limited access, so we can create 3 passwords. Everything can be scripted. The same, but harder. Keep your safe, your network safe. We know that it's difficult to create a network. So, well, pieces of advice, quick advice. We have to say that everything we have said is like the tip of the iceberg. There are much more work behind that. We want to continue. And note that everything generated, touched by production is critical by extension. But note that all these new waves of automation are moving problems left, but we have to always move security to the left too. There are many things to say, but we haven't had time to expose it. But we're creating a free book with all these extended. You can read online. It's a GitHub link, and the part on the left is like a small project that we're creating, assembling all these things that we have said. I don't know if you have tried to implement it at your work or companies or just by leisure, but most of them don't exist or are expensive as hell, or it's not possible then anymore. So as there's nothing like when you do things for you, we have created this project. We didn't have time to bring the demo. So if you want to warn you when we have it, so you can use it, or if you want to warn you when we transcribe the slides and we put it organized and with screenshots, and if you want to contribute, it's GitHub. You can make it public and contribute if you want. You can leave your mail. We won't send any spam or sell anything. We are paid by other people. There's no need to do it. So now that should be it. We have 3 minutes left. Being strict. Okay, that's it. From our side, that's it. Thank you very much. The other speeches, they're waiting to start. So unless it's a very interesting question, I please beg you to talk to them now. Now they leave. And we conclude with this talk because we are running out of time. Thank you very much.